Refractive index of a medium relative to air is 1.8. Calculate the critical angle for the medium to the nearest degrees. The point of interest in this question is critical angle. Let's make a sketch and identify some important points. Here is the normal line, and the ray is going to come from a place of more to a place of less index of refraction, which is nm and nl. Okay, because of we are talking about critical angle, light must travel from more index to a low index. Now, the angle of incidence when the refraction is 90 degrees is what we call the critical angle C. So here is 90 degrees. That is the refraction for that particular angle of C. So for C to occur, refraction must be equal to 90 degrees. That is what we mean by critical angle, which is the angle of that incidence at that point when R is 90 degrees. So here, Nm must be greater than Nl. In this case, Nl is the air, and Nm is the place with more index of refraction. From Snell's law, N of the place with more index, sine of the angle associated with that place, in this case for critical angle, and N for air multiplied by sine of the angle of refraction, in that case 90 degrees. Now, the more index of refraction has a value according to the equation as 1.8. So here is 1.8 multiplied by sine of the critical angle, which is in this case we are looking for. N of air is constant, is 1, times sine 90 is also 1. Okay, refractive index of air is 1, just keep that in mind. So to get the C value, you can get 1 divided by 1.8. Okay, if you press that in the calculator, you should get 0.5556. You can check that out in your own calculator. Now, to get C value, I'm going to take sine inverse of the value which we've just got it from the calculator. If you press this in calculator, you should get about 33.75 degrees. But the question said to the nearest degree, that should give us 34 degrees. Thanks for watching and have a nice day.